Einstein's gravitational waves detected in scientific milestone. What is this? What has led up to this? And how was it finally discovered?
This was just announced hours ago.
Yeah.
So you don't miss anything here. Look at you.
No, I saw that it popped up as an alert on my phone.
Yeah,
as
it should.
Oh, okay. This is
100 years in the making here. Einstein, 100 years ago, 98 years ago, I think it was, gave a recipe for a prediction of how you might be able to detect the kind of gravity that he described in his famous 1916 paper. To him, gravity was not a force of attraction between objects, as Newton would have you think of it. Gravity is the distortion in the fabric of space and time. And if I have a massive object, I'm distorting it deeply, and some other object comes in the vicinity, it kind of falls into that distortion.
Right.
So you're really just staying with the flow. And I think it was one of Einstein's disciples who came up with the phrase, mass tells space how to curve. I got to say this right. No, it's very pithy. Excuse me.
Don't worry, you got me.
No, matter tells space how to curve. Space tells matter how to move.
Oh, okay.
There you go. And so now, if you have a disturbance in this fabric of space and time, it will emanate forth as a ripple moving at the speed of light. And that ripple that was discovered and announced today has been traveling through the fabric of space and time for 1.3 billion years. And it is the record of the collapse of a double black hole system coalescing into one black hole. And that is a major disturbance in the fabric of space.
So in order for that to be detected, it would have had to have been this giant, like obviously anything probably throws off gravitational waves.
Yes, anything.
Then to make it
correct
to reach here,
it's got to be big enough and bright, bright enough, if I can use
like
that word.
Tsunami of gravity.
Correct. And so badass black holes coalescing is what did it. And in fact, in the last instant before these black holes coalesce, it is radiating so much energy. It is more energy than all the stars of the universe combined. But it only does it for a quick fraction of a second.
It's enough
before they coalesce. But it's enough to give that little jiggle, wait 1.3 years, and it came across the detectors, changing the length between two mirrors that are suspended on very thin wires in multiple observing locations in the world. And by the way, you know how much the length changed as the ripple went across? A fraction the diameter of an atomic nucleus. It is the most precise measurement ever made by far.
That's detectable.
Anything. Yes.
With a mechanical
yes.
setup.
Yes. And in fact, the insulation of this, I visited.
I guess they don't leave them out like wind chimes.
That's what I'm saying. So I visited one of these facilities just a month ago in Louisiana. There's one there. There's one in Hanford, Washington State, and they're building others around the world so that you don't want to detect it only in one. You want to make sure multiple ones detected. There's no funny business, or you can have confidence if you have the exact signal in more than one detector that it's real. All right. So I'm there, and you drive up to the facility. It says, beam on, drive slowly, or something. Any vibration will affect this thing. Vibrations on a level that is so sensitive. It can detect the quantum vibrations of molecules in the wire that's holding the mirror.
God. How is that accounted for?
Well, so now they got to account for. I mean, it's a very.
What about seismic stuff that's unpredictable?
Well, so it's one of the world's greatest seismic detectors.
I bet.
So no, there are ways to insulate it from whatever's going on around. So it's a masterpiece of engineering.
Amazing.
Yeah, and it'll Nobel Prizes all around for everybody. Yeah.
I gather. So what does this mean? We always hear how important these discoveries are. What will this teach us?
Well, it is. I don't know that there's anything left that Einstein predicted that we can still end up finding out is true. Everything has been correct. And in fact, let me tell you how smart Einstein was. In one of his equations, he put in a term that he later regretted putting in, and he called it his greatest blunder. This is a term that he looked at his equations, and his equations showed that the universe had to be either expanding or collapsing.
Right.
Now, no one had any idea that the universe, which is everything, would be doing anything.
Yeah, it's just there.
It's just there,
Right.
right? So he says, this can't be right. Let me put in this term. It's a legitimate mathematical term, but physically, what the hell are you doing, Albert? And he says, this term will help stabilize it from collapse. Okay, and it's a pressure force to push outward, and that'll stabilize it. Later on, just a couple of years later, Hubble, the man after whom the telescope was named,
Telescope the man.
discovered that in fact the universe was expanding, and he didn't need the term because he could have predicted that the universe should either be expanding or contracting, but he didn't. He put in this term. He said it's his biggest blunder. Now, you know what Einstein's actual biggest blunder is? Saying that that was his biggest blunder.
Yeah.
Because in fact, in 1998, we discovered a pressure in the universe pressing against gravity that is exactly the term that he put in.
It wound up being what he said.
His
not
biggest
a blunder at all.
blunder is thinking he made a blunder.
Uh-huh.
That's how smart he
How-
is. That's badass smart.